Hello everyone, welcome back to the another session in design and analysis of algorithms. Topic name is 0 by 1 Knapsack problem using dynamic programming. So this topic you will find in third unit as topic number 10. This video will be going to cover three things. The one is what is 0 by 1 Knapsack problem, and the second one is how to apply dynamic programming on this problem to solve. And there are two different methods to solve this problem. The one is tabulation method, the other one is sets method. So with an example we'll see how these two methods will be useful. Now let's get started to understand what is 0 by 1 knapsack problem. So basically a knapsack is what? It's a container or it is a bag. So in this bag we wanted to place some items where, keeping in the mind the constraints or two, which is always the profit should be maximum. When you place the set of objects in this bag, the sum of all the profits of the item should be maximum. And the second is the weight of all the items should not exceed the capacity of the bag. So we'll keep in the mind these two things and we'll find the solution for the problem. The solution is what? A solution to the knapsack problem can be obtained by making a sequence of decisions on the variables x1, x2 up to xn. So these are what the items what I wanted to place in the knapsack or in the container. So what I'm going to do is, as far as dynamic programming approach is considered, we will be going to take a sequence of decisions. That means, can I place x1 only, or can I place x1 and x2? Can I place x1, x2, x3? So we will be going to take a sequence of decisions. All these decisions are to be in line with maximum profit and not exceeding the capacity. A decision on variable xi involves determining which of the values 0 or 1 is to be assigned to it. That means we cannot place the item which is half, the way how we were done in greedy method. In greedy method, 0 by 1 knapsack problem is fractional knapsack problem. To make this capacity in the greedy method, we were taken even fractional part of the item. But whereas in the 0 by 1 knapsack problem, when you are applying dynamic programming, you cannot do fractional part. You have only the way of keeping the item, or you are not keeping the item into the container. That's it. That's what we are representing it with 0 by 1. That means 0 or 1. Item can be placed, item may not be placed. Let us assume that decisions on the xi are made in the order xn, xn minus 1, x1. So in stage wise, we'll take a decision. Following a decision on xn, we may be in one of two possible states. Capacity remaining in the knapsack is m and no profit has occurred. Or the capacity remaining is m minus wn and a profit of pn has occurred. Now, we'll take an example to place in the knapsack. The placing items are x1, x2, x3. These are what the items what I wanted to place in the container. Now my container or my knapsack, the bag capacity is m equal to 6. Now we were given with the profit and the weight. Profit should be maximum. Bag capacity should, after you place the items, bag capacity should not be exceed. So we will be keeping in the mind these two things and we'll get the solution for the problem using dynamic programming approach. Now let us think first of all what the way we will place the items. Now, so as I have the first item, think whether I can place x1 item into this bag. If I place x1 item inside the bag, what is the profit? If I place x1, I'll get the profit which is 1 and the weight is 2. So the total capacity of bag is 6. I am utilizing only 2. So still 4 capacity is left. 6 minus 2. 6 is what? M. 2 is what? Weight of particular item. That means Wi. So M is 6, Wi is 2, and still 4 weight I can utilize for the next object. So I am placing x1 in the container. Now, so as you have this 4, now again go back for x2. So when you have x2, think about to place x1 and x2 inside of the bag. So already I place x1. Now, do you have any chance to place x2? Think about it. So that's what I'm writing the combinations. The first combination is no item is placed in the bag. The next is what? 0, 0, 1. That means third object is placed. This is what third object, x1, x2, x3. And second object is placed. And second and third is placed. One only the first is placed. So likewise, as I have n value is 3, how many combinations I'll get? 8 combinations I'll get. That means 2 cube combinations. 3 is your n value. That means 2 power n combinations will get. That is the time complexity is big O of 2 power n. So this is what the complexity placing of item inside of the container with these 3 size, right? Now we will apply dynamic programming. Half the way we will make items inside of the bag. So now I'm taking some example. This example I took from the textbook only. Preferably I'm giving all the examples from the textbook, prescribed textbook. Okay, if textbook is not having any example, unfortunately, then I'm getting the example from the previous question papers of OU. Now, so this example is what? We do have some n size. N is what? 4 items that you can see here. We were having 4 item profit, 4 item weight. So bag capacity is 8. Now, this 0/1 knapsack problem using dynamic programming can be solved using 2 approaches. One approach is tabulation method. The other approach is sets method. We'll discuss the both as I said in the beginning of this presentation. Now, so I'm taking some table. I'll tell the use of this table also when time comes. Now, here in this table, the way how I'm keeping all the items are, these are what? Weight. Because when you look at the bag, all 8 kgs of weight we will not keep inside of the bag, right? We'll keep inside of the bag step by step. That will make it happen that 2 kgs are utilized by some object and 3 kgs are utilized by some object. So put together we will be coming for m is equal to 8. So that is the reason why I have divided this figures up to 8. So I'm not going beyond of 8 because my bag capacity is only the 8. So these are what? Weights. Now this box has to be filled with the profits of the items. Okay. Now, so the way how you have to proceed is, this is your bag. Assume that this is your bag. So in your container, which item you are placing? These are what? Your items. X size. Now 0 item is placed. When 0 item is placed inside of the bag, obviously the profit is 0 itself. So make it all zeros. Now the next is, you have first object. So I told you in the beginning that dynamic programming will works with optimality of principle. What is optimality of principle? Problem can be solved by taking sequence of decisions. So sequence of decisions means what? Here, when you have only the first object, we will be thinking up to the first object. When you wanted to place the second object, so we will be having 2 objects in our hand. Then when you have third object, we will be getting third also. And the fourth object, we will be going for even fourth. So these are what the sequence of decisions. When you have x1, you will be placing the x1 inside and you will check the profit of it. When you are coming for x2, because bag capacity is not utilized by 1. When you place 1, the weight is what? 2 only. So still 6 kgs of weightage, 6 kg of weight you can utilize. That's what you are going for the second object to place. When you wanted to place second object, you cannot give priority for only second. You have to come for 1 and 2 objects. Now, so after you place second also, if you have any place, any bag capacity is still there to utilize by the other object, now point is comes into our mind, the profit. If I place these two objects, what is the profit? If I place these two objects, what is the profit? So obviously we'll take maximum profit itself, right? So this is optimization problem. It will choose the high profit. Now I wanted to place the first object. When I wanted to place the first object, what is the weight of the object? First object weight, that's what I wrote here. First object weight is 2. So I'll change the ink. First object weight is 2. Now, so these are what weights I told, right? Now, so this is what 2 weight. So here the weight of the first object is 2. That's what I'm making here 1. 1 is not indicates object. 1 indicates profit. Profit of first item. Okay, because I told you that this table will get filled with the profits of the items. Now, 2 is the weight of first object. Now I'll get the profit 1 if I utilize 2 weight for the object 1. Now, what values I have to take over here? Whatever values you have in the above, that the values will be come for the next step. So the profit remains same because I have only one object in my hand. Now come to the second object. For second object, you have 2 objects to consider. When you have two objects, these are what the same values because no object is having one weight. So what is the weight of your bag? 8. But weight of your objects are what? 2 and 3. So maximum weight what you will utilize? 3 you will utilize. So come to 3. 3 you are placing 2 because the profit of second object is 2. So it is previous value as it is I am writing. Now, so at the weight of 4, you cannot place any item. So as it is you are writing. At the place of 5, when the weight is 5 of the container, then you can put these 2 items together, right? First object and second object you can put over here. That means the profit is 3. 1 plus 2 is 3. And the profit remains the same 3. Okay. So now your bag is having 2 items. Now come to the third step. How many items you have? 1, 2, 3. 3 items you have inside of the bag. Now here a very important thing is when you have these 3 items, what items you have? X1, X2, I'll write here X1, X2, X3 items you have in your hand to place in the container. Now X1 weight is 2, X2 weight is 3, X3 weight is 4. Bag capacity is only 8. If you keep all the items inside of the bag, it goes beyond of the bag capacity. 4 plus 3, 7 plus 2, 9. So it goes beyond of the bag capacity. But we do have a constraint that bag capacity WXI should not be greater than the size of the bag. That's what you cannot place all these 3 items, but you can place any 2 items. If you place 4, 3, X2 and X3, the bag capacity will be utilized only 7. If you place X1 and X3, bag capacity will be 6. So whichever will be give highest profit, that will take. Now look at these 3, which will give highest profit. If I place first item, the profit is only 1. If I place second item, profit is 2. If I place third item, profit is 5. So let's see second item, third item, the way how we will store. So obviously these values will get 0 because no item is having one weightage. one weight, so we'll keep the values as 0, I mean the previous values what we have. Now this is also same, because in when the weight of the bag is 2, we'll place the first object. When the weight of the bag is 3, we'll place the second object. Now come here. When the bag capacity is 4, now what we will be going to do is, now which item you have? X3 item. X3 item is what? 4. Weight of 4. The profit of X3 is what? 5. So write here 5. The weight is 4. X3 item weight is 4. That's what X3 item is getting placed in the table. Now here I am writing only profit. So I write here 5. Now the same value will be writing for 5. And now for 6. 6 is the weight of the bag. Do I have any item to place? Yes, X1 I can place over here. If I place this item, now bag weightage will be what? 4. Already 4 is there. 4 plus 2, 6. Correct? So second item also I am placing. Now 5 plus 1 is 6. The profit is 6. 6. So how much weightage we were used? 4 plus 2, 6 weightage we were used. 6. And now when bag capacity is 7, now what item I am placing? This item I am placing. Okay, which item? X2 item I am placing. When X2 item is getting placed into the 7 kgs, I mean in the weight of 7, now what is the profit? Already 4 is utilized. So 5 plus 2, 7. 5 plus 2 is 7, so 7. Right? Now X4. X4 0 0, already 1 placed, and your 1 2 items placed, and your even X3 also placed. And now for 5 weightage, already we do have which item? This 4 item, right? 4 item is what? Profit is 6 and the weightage is 5. So wherever it is 5, there I am writing profit is 6. Now 6 7 8. Now what we were done is, according to the sequence of decisions, we were placed inside of the bag. Now you have to check for which values the bag capacity and the profit constraints will get satisfied. So we will be doing even using of the formula. The formula we were seen in the before slide, right? The formula is this. The formula is this. So how to calculate the this values, the table values? We were given values as far as table is considered, but we do have a formula to find out the values in the table. The formula is, let fj of y be the value of an optimal solution to a knapsack. Since the principle of optimality holds, we obtain fn of m is equal to max of fn minus 1 of m, comma, fn minus 1 of m minus wn plus pn. We'll use this formula to calculate at least one cell of the value, so that you will be having confident to move forward, right? Now we will take that value. We'll calculate for 1. Now we'll take this we'll take the last row values, whatever values we got, the last row values I'm taking, because I'm going to calculate using of the formula the values what we were just now got from the previous example. These are what the last column, last row. If I place 4th item, these are the values. Now apply the formula to check the same. Now the formula is vi comma w is equal to max of vi minus 1 comma w comma vi minus 1 comma w minus wi plus p of I. This is the formula. Now I is what? The item what you wanted to place. So item is what? 4. Now 4. W is what? The weight. The weight. Now I am taking weight which is 4 comma 1. Now max is max of V of I minus 1. That is, it is I is 4, I minus 1 is 3 comma W weight is what? 1 comma V of 3 comma, because it is I minus 1 again. Now W minus Wi 1 minus 5. This 5 is what? Wi. I value is 4. Weight of this 4. Weight of the 4 is what? In the problem we were taken, right? So what is the value? P is equal to 1 comma 2 5 6. W is equal to 2 3 4 5. Now the last item, the fourth item weight is what? 5. Now that's what I wrote here, 5. 5 plus PI, that is profit of the last item, which is 6. Now calculate V of 3 comma 1. In the table, V of 3 comma 1 is 0. 0 comma V of 3 comma minus 4 plus 6. Now this value is what? Undefined, because we did not have a negative index, right? We do have 3 comma 4 index from the table, but we don't have 3 comma minus 4. So it is undefined. That means we will take the value as 0. So for 4 comma 1 value is 0. Now these are what the indexes. So 4 comma 1 value is 0. Now, so you can take the same way to get all the values. So now we will see even the other value. V of 4 comma 5 is equal to max V of 3 comma 5 comma V of 3 comma 5 minus 5 plus 6. That is max of 5 comma 0 plus 6. From where I got the 0? 3 comma 1. The value of 3 comma 1 from the table, it is 0. So which value is maximum? Maximum value in between 5 comma 6 is 6. So we'll update the value of 6 in the place of 4 comma 5 in the table. In the same way, you can calculate 4 comma 6. You'll get max of V3 comma 6 comma V3 comma 6 minus 5 plus 6. Max of, from the table, V3 comma 6 value is 6. From the table, V3 comma 1 value is 0 and plus 6. Max is 6. So you can find the same values in the table. Though you apply table values, though you apply this formula, you will get the same values. Right? Now, so what we were done so far, we were taken sequence of decisions to see which item can be placed in the bag. So that was we were done so far, right? Now the thing is, we do have x1, x2, x3, x4. Now in the last table, the last row of the table is maximum profit. We found at it is 8. That means what? If it is a maximum profit of the entire this problem, then who will give this maximum profit? When we got this maximum profit, in the fourth row you got this maximum profit. Not in the 1, not in the 2, not in the 3. That means maximum profit is not from placing first object, second object, third object, but in the placing of fourth object. That means for sure you should place x4 to get maximum profit. So x4 item has to be inside of your container. So when you place x4 item, actual capacity of your bag is what? 8 minus. What is the weight of this bag? What is the weight of this item? 6. 8 minus 6 is 2. Okay. The 6 is what? Profit of x4. So leftover weight is what? 2. That means still this weight you can utilize. Now, so which value giving this to? That you can check from the table. That the weight of x2 is what from the example? that we will be placing x2 item. So x1, x2, x3, x4. x4 is placed, x3 is not placed, x2 is placed, and this. Now what is the profit of x2? Profit of x2 is 2, profit of x4 is 6. That means we got 6 plus 2 is 8. Now bag capacity is x2 capacity is 3, x4 capacity is 5, bag capacity is 8. So finally, which items we were placed inside of the container? x2 and x4. So this is from the tabulation method. So now we'll see about sets method, how it works. Sets method is what? So the same, but the formula is getting changed. That also we'll see. Let us suppose the same example. We'll go quickly to, we'll make all sets for each stage. That is the first stage. S0 I'm indicating with. So in the S0, 0 comma 0, that is no item inside of the bag. That is no profit, no weight. Now consider the first object into inside of your bag. That is S1 of 0 is equal to, what is the profit of first item? 1. What is the weight of first item? 2. That 1 comma 2 is a set. Now merge these two sets. Now that set is S1. S1 is equal to 0 comma 0 and 1 comma 2. That means first object is not included, first object is included. Now again S1 dash is equal to, after you place first object, now you can place second object too. Second object is what? Profit and weight. Second object is 2 comma profit and weight 2 comma 3, and this is what? Addition of both. That means 2 plus 1 is 3, 3 plus 2 is 5. This is the set. Yes, 1 dash set is 2 comma 3, 3 comma 5. Now S2 set is equal to merging of these two. S1 set, S1 dash set, merging of these two. Now that is 0 comma 0, 1 comma 2, my first object is placed, 2 comma 3, my second object is placed, 3 comma 5, I placed 2 objects. This is my S2. Okay, now we'll place third object. Third object, if I place the third object, then it is S1 of 2 is equal to, third object is what? 5 comma 4. That is 5 comma 4, 6 comma 6, 7 comma 7, 8 comma 9. So this is your third object, and adding of these values to the existing. So we'll get this. Now so look at this, all these are P comma W values. So bag capacity is what? 8. So this is going beyond of bag capacity. That's what I'm ignoring the value, or I'm cutting the value from the set. Now S3 set is equal to 0 comma 0, no item is in the bag, 1 comma 2, first item is in the bag, 2 comma 3, second item is in the bag, 3 comma 5, both the items are in the bag, 5 comma 4, third item is in the bag, 6 comma 6, third item and first item is in the bag, and 7 comma 7. Now third item and the second item is in the bag, and 8 comma 9. So I told you 8 comma 9 should get ignored, because as it is the going beyond of that capacity, I'm not going to take that. Now the above is the set 3, where if you look the set 3, observe this profit and weights. Profit and weight. Profit and weight. Here look at this. Profit increases, weight also increases. here it is 0 initially, now it got 1. So profit increases. Proportionally weight is increasing. Profit is increasing, weight is increasing. Profit is increasing, weight is increasing. Now see here, profit is increasing but weight is getting decreased. That's why the order pair are wrong. So we have to discard, and even so we will discard the smaller profit, which is 3 comma 5. We have now 6 order pairs. Those 6 order pairs are what? 0 comma 0, 1 comma 2, 2 comma 3, 5 comma 4, 6 comma 6 and 7 comma 7. Cutting of this 3 comma 5 is called as dominance rule. So with the dominance rule, the values order pairs which is not correct, that we will cut from the sets. Now the values order pairs which are 0 comma 0, 1 comma 2, 2 comma 3, 5, 4, 6, 6, 7, 7. Now what we have to do, add the other item. Now what other item? The last item I am going to add as 6 comma 5. Now again fourth item and the first item, 6 plus 1 7, 5 plus 2 7. The same, 6 plus 2 is 8, 5 plus 3 is 8, 6 plus 5 is 11, 5 plus 4 is 9, 6 plus 6 is 12, 5 plus 6 is 11, and 6 plus 7 is 13, 12. So these are what the values what we will get from the set, correct? Now very interestingly, whichever item is going beyond of the bag capacity, that all will get cancelled, will not take that values. So finally our S4 set is what? Our S4 set is equal to 0 comma 0, 1 comma 2, 2 comma 3, 5 comma 4, and so look at this. So here it is 6 comma 5, right? 6 comma 5 means what? Your profit is high but weight is low. So what item we will be ignoring? 6 comma 6 item we will be cutting out of the picture. So now 5 comma 4, next 6 comma 6 we cut it, and 6 comma 5 and 7 comma 7 and 8 comma 8. So these are what the sets of the these are what the pairs of the last set. So once after you got the last set, now you should know what items are going to be placed in the container. That is maximum profit you gain for the last set. That means 8 comma 8 is belongs to S4, but 8 comma 8 pair you cannot see in the S3. So it senses that X4 item is included, not X3. Correct? Now when you place X4 item, then what is the bag capacity and what is the profit of the bag? After you place X4, that is 2 comma 3. Now let's see whether 2 comma 3 pair is there in the any other set. 2 comma 3 pair is belongs to S3, but 2 comma 3 is not belongs to S2. That means X3 item is not placed, and 2 comma 3 belongs to S2, but 2 comma 3 not belongs to S1. That means X2 is included. When X2 is included, 2 minus 2, 3 minus 3, which is 0 comma 0. So bag capacity is equipped, or we utilize it completely with the X4 object and with the X2 object. So finally, out of these 4 items, what items we were placed? X4 item and X2 item. So this is what 0 by 1 knapsack problem, and I have explained you sets method and tabulation method and using dynamic programming. These are what sequence of decisions to place the item inside of the bag. Thank you all.